So let's look at this equation. X squared plus 2x minus 2 equals 0. I want to solve this equation. So I might start off just by trying to factor. I get an x here and an x here. I need two numbers whose product is 2 here. That's going to be a 1 and a 2. In some order, I could write the 1 first. But I'm going to run into some trouble here because there's no way I can get plus or minus 1 and plus or minus 2 and get 2 total. If I take a 1 and a 2 and I either add them or subtract them in either order, I'm never going to get 2 with a 1 and a 2. So this doesn't work. So what's an idea that I can use? Well, I really liked problems that had something of the form x squared equals a constant, or x minus some number, well, let's not use a because we're using that for the coefficient of x squared. Let's use k. These are really easy for me to solve. I immediately take plus or minus the root c, and then I can add the k over to the right if it's there, or I'll just be done in 2 steps. In this case, in 1 step. In this case, life would be very good. So if I can write this in this form, I would like that very much. So what might I be able to do? Well, let's think about that. I have a rule that tells me that x plus a squared is x squared plus 2ax plus a squared. So here I have x squared plus 2. Well, that looks a little like this. Looks a little like this, except I would want an x squared plus 2x plus 1 in order to make this work, right? Because if this is 2ax, then a would need to be the number 1. So x squared plus 2x plus 1 would be nice. It would be in this form. I could do this, and then I can use one of my rules. So I really, really want this. But that's not what I have. I don't have that. This is the equation. So what can I do? How can I get 1? Well, there's really going to be only 2 tricks in this class, like 2 sneaky tricks, but they're sneaky, but they happen again and again and again. And those tricks are, we're always allowed to multiply by 1, and we're always allowed to add 0. Those are things we can always do. So I'm going to add 0. You see, I'd like to add a 1 to this equation, but that would change the equation. So what could I do? I can add 1 and then immediately subtract 1. This equation is now the same as this equation, because what I did is I added 0. So at this point, I can use my rule. I have something of the form x squared plus 2ax plus a squared. I group this together, and I get, well, what's my a? My a is 1, so I get x plus 1 from this part. And from this part, I get minus 3 equals 0. And this is squared, because we're using this rule, so we have a square. And now we get x plus 1 squared equals 3. That immediately tells me that x plus 1 is equal to plus or minus the square root of 3, and that x is equal to negative 1 plus or minus root 3. And now our problem is solved. So, what did we do? We had something like this, which we couldn't factor. I wanted to solve it anyway. I wanted to get something squared equal to a constant. Well, how do I do that? Well, I had this formula from before, and I wanted to use it. I didn't have the number I wanted in order to make this formula work. So what did I do? I added it. But I'm not allowed to just add it. That would change the problem. So I also subtracted it. Then by grouping this into this and this, I got x plus 1 squared from these first three terms and minus 3 from the next two terms. And the rest of the problem was just me using that one rule that we have for radicals. So we'd like to do that in the future. However, you might say, hey, this is a little tricky. How do I know what number I have to add and subtract? Well, we'll go over that next.